Okay, in this video, we want to introduce the idea of a derivative. And so to get to what we will eventually call a derivative, we first discuss this concept of what's called a tangent line. So the idea is if we have a curve here, and we're looking at a line that's basically going in the same direction as the curve at a given point, that thing's called the tangent line. Let me give you a little bit more of an impression of what a tangent line is here. So here I have a function here, y equals 4 minus x squared. And I'm drawing in here what is its tangent line. Now I can adjust this, by changing the points on my slider. And we have this tangent line. Of course, it depends on what x value it is. Will dictate what tangent line we're dealing with. Now, what the tangent line is, if I take a look at my graph, take a look at my graph up to some point and just stop the graph. Imagine for a moment that you're walking along this graph and you stop at that point. Well, the tangent line will be the direction that you're currently pointing in. Right? Will be the direction that you're currently pointing in. That will be the rate of change of the function at that point. Okay? That is your tangent line. It's the line that's going exactly the same direction as the curve. Now the curve is changing. So the curve isn't always going to be there. It's going to, at some point, stop, right? So that it's not going in that direction anymore. But our tangent line will still be pointing in that direction. And so that's what the tangent line is. It is the line, again, that is moving in exactly the same direction as the function at that point. So the idea being, if that was your path, or that you were walking around, or if you wanted to think of this like you're on a roller coaster and you're looking straight ahead, this would be your line of sight. And as you get to the top of the hill, your line of sight starts to level out, and then it's like, oh boy, I'm going down that hill. Okay, so the tangent line is just the direction that you're currently going at that point. And what it can measure then is how steep the curve is at that point. Okay, so that is called the tangent line. That is called the tangent line. Now our goal is to find the slope of that tangent line. We'd like to know what the slope of that is. There's just one problem. That tangent line only has one point that we know of. And that's that point where the line coincides with the function. And we know that we need to have 2 points to be able to come up with the slope. So what we do is we turn our attention instead to secant lines. Secant lines. Secant lines are lines that are passing through 2 points on the curve. In the illustration here, I have x f of x and x plus h f of x plus h. This should look familiar because this slope of a secant line here is actually, one of those difference quotients that we talked about at the very beginning of the course. Okay, so that is the slope of the secant line. And so we're going to look at secant lines. And so here I have a picture of a curve, and I have my tangent line drawn in. And we'd like to be able to figure out the slope of that tangent line. Big problem is, again, we only have 1 point. So instead, we look at some secant lines. So I pick some other point on my curve and find the line going through that point and my red point. And because I have 2 points, I can talk about the slope of that line. And I'd be able to figure it out. Now, not only can I figure that out, I can also see from the picture that the blue line's not as steep as the red line. So the slope of the red line is going to be bigger than the slope of the blue line. So I pick a second point here. And again, look at that secant line. And here I notice that the green line is steeper than the red line, so its slope's going to be bigger. So if I know the slope of the green line and the slope of the blue line, then I could estimate the slope of the tangent line, knowing it's got to be in between those. Now watch what happens when I pick a point even closer. Consider this yellow point here. I'm getting even closer to the slope of the red line. And so I can keep getting closer and closer to the red point, picking points that are very close to it, to get an idea of what the slope of the red line is. Now, I can't actually evaluate it, but that's where our idea of a limit comes into play. That's where the idea of a limit comes into play, because now we can think of taking the limit of these secant lines, and that will give us the tangent line. And so the result is this. The slope of the tangent line is the limit as h goes to 0. Again, h being in that difference quotient up above. We're letting the second point basically become the first point. Limit as h goes to 0, the slope of the secant lines would give us the slope of the tangent lines. And that's where we get our formula here. Slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x all over h. So it's the limit of that difference quotient that we talked about before. Except instead of now just computing the difference quotient, we're going to allow that h to become 0, approach 0, take the limit. And that's what's eventually going to be called the derivative. And so we're going to take a look at using this in the upcoming videos.